Hello everyone. I'm going to do this in 3 videos. You guys are going to see one per each page. I'm going to just take a look at the Chapter 5 test review and work through these problems kind of right along with you. So I'm going to zoom in here and we're going to start with the first one. Like I said, this is going to be the first of 3 videos. We're going to do one page at a time, so I'll try to keep these brief. Here, it's important to know what you're doing, right? So in this case, we are simplifying, right? So we need to do what we can until we think we are done. So on number 1 here, I don't like secant and I don't like cosecant. So my first move here would be to rewrite secant from the denominator in the numerator. That's going to create cosine squared A. And then doing the same thing with my other term, cosecant is the reciprocal of sine. And now I get sine squared A. Now that rings a bell to me. That is one of our cosine double angles. So we can simplify this down to cosine 2A. That's as simple as we can get. Let's look at another one. Here's number 2. And again, this seems familiar to me. I see that 1 minus 2 cosine squared, but it's not quite right. I know that cosine of 2b is 2 cosine squared b minus 1. So if we were to factor a negative 1 out, we would create that exact identity. So now I'm going to replace 2 cosine squared b minus 1 with cosine 2b. Like the first one, it's all about recognizing these formulas, these identities in the wild. Let's move on to a similar problem on number 3. Now there's some things I like about this problem and there's some things I don't. Right? I see the sine times cosine of an angle, and even looking at the angle, we see its denominator is 12, so I'm thinking this might be something like a double angle. However, this 4 right here is a little different. I know that the sine of 2a is 2 sine A cosine A. So basically, I'm going to rewrite this as 2 times sine, what ultimately ends up being A times cosine A, and we've created the sine double angle. All right, so this 2 is still going to be there, but we can replace 2 sine A cosine A with sine 2A. Now in this case, A was 5 pi over 12. If we were to double it, that would give us 5 pi over 6. Now we know that we actually can find the sine of 5 pi over 6. We know that it is 1/2. So all of that work leads us to the conclusion that for sine of 5 pi over 12 times cosine of 5 pi over 12 is just 1. All right, let's keep moving here. On to number 4. All right, now let's take a look at number 4. As I approach this, I see it's another simplified problem. I don't have, one equals 2, so I can't work on one side or the other. All I can really see here is the sine of 2x and the minus 1. I'm going to create a common denominator, and I'm going to use my double angle. Right? I'm going to do both those things as my first step. So I'm going to write this as 2 sine x cosine x plus cosine x. Well, the common denominator of 1 is going to be cosine x, so minus cosine x all over cosine x. And now I can see there's going to be some simplifying here. I can see that these will cancel, as there's one positive and one negative. And then I have cosine x divided by cosine x. Well, they will also cancel. So when this is all said and done, our simplest form will be 2 sine x. All right, one more problem on page 1. Oh, excuse me, there are 2. It looks like we do get a verify problem here. So I'm going to work on that messy looking left side, and I'm going to distribute it. I'm not sure exactly what's going to happen, but I have a feeling that some things are going to start falling away because I have negative sine y, positive sine y, positive cosine y. More than anything here, I'm just going to see what happens, right? 1 times 1 gets us 1. 1 times sine gets us sine y. 1 times negative cosine y gets us negative cosine y. Our second distribution here, I'll just change colors. Negative sine, we're going to have a minus sine y here. We're going to have a minus sine squared y. And we're going to have a plus sine y cosine y. And then for our third batch of distribution, I'm just going to change over to blue here. I get a positive cosine y. I get plus cosine y sine y. And finally, I get minus cosine squared y. I'll put this over here. So I'm going to combine all my like terms here and rewrite as a single expression. Well, let's start. Well, the sine y's cancel. The cosine y's cancel. So let's say negative cosine squared y minus sine squared y plus 2 sine y cosine y. And in my head, I'm feeling pretty good about things because that 2 sine y cosine y is very much what the sine double angle looks like. So now I need to deal with the cosine y and sine y. Well, I know that sine squared is the same as 1 minus cosine squared, right, with a Pythagorean. All right, if I were to take negative cosine squared y minus that, I would have, well, now I have a negative cosine and a positive cosine. Oh, you know what? I dropped my 1 as well. There should be a plus 1 here. And what we can see is that this minus 1 will cancel with that plus 1. That plus 1 I overlooked was right there. So when it's all said and done, all the other stuff has canceled, and we're left with 2 sine y cosine y, which is the same as the sine of 2y, which is where we were going. So in this case, we distributed, and we were able to cancel quite a bit. All right, guys, one last problem here. All right. Now we have negative 2 cotangent x equals sine x over 1 plus cosine x minus 1 plus cosine x over sine x. I'm not sure where we're going to end up, but my first instinct on a problem like this is to create a common denominator. I'm going to create that common denominator by multiplying by the other denominator in the problem. I'm going to create sine squared x minus 1 plus 2 cosine x plus cosine squared x. Good. So now what I can do is I can start rearranging things. I know that if I'm heading towards negative 2 cotangent x, I know cotangent x is, I could expect something like this as my second to last step. So I kind of like seeing that 2 cosine x in my numerator. Now I got to deal with all the other stuff. So I'm going to rearrange things, and I'm going to write that numerator as sine squared x minus cosine squared x minus 1 minus 2 cosine x. Now as I look at this numerator, I can do some simplifying. I'm looking at the sine squared minus cosine squared. Well, I know that sine squared x plus cosine squared x equals 1. And I think what I want to do is I'm going to replace sine squared x. So sine squared x is the same as 1 minus cosine squared x. So we could say 1 minus cosine squared x minus cosine squared x minus 1 minus 2 cosine x. Well, still working in the numerator here. Don't forget, we do have that denominator. I will come back to it. I'm just working in that numerator. So the next step, I would combine my like terms. I have negative cosine squared minus cosine squared. So there's negative 2 cosine squareds. I also have 1 minus 1, which is 0. And believe it or not, we're almost home. So what we're going to do as our last step, our second to last step, is we're going to factor negative 2 cosine x out. And what will be left is cosine x plus 1, which I'm hoping you remember was part of our denominator. Now I have cosine x plus 1 with 1 plus cosine x. I can cancel those. I can see that what remains is negative 2 cosine x over sine x, which is the same as negative 2 cotangent x. That's what we're after. So that's our first of 3. Stay tuned for sections 2 and 3.